Hi, my name is Victor Young.
And my name is Forrest Young.
Our project is called Computerpreter. We wish to optimize deaf accessibility through real-time American Sign Language translation. The problem right now with 11 million deaf and severely hard of hearing people in the US is, first of all, writing, lip reading, and typing are slow and erroneous, ineffective communication methods. There's also a lack of interpreter, so they're only really used in planned events. And third of all, there is discrimination. So our solution is Computerpreter, a Streamlit app that opens the camera and starts live video translation using first a random force classifier for fingerspelling detection, and second an LSTM for dynamic ASL signs detection. We specifically used an LSTM to handle sequential data, like moving signs. Previous techniques, like 2D convolutional neural networks, are fundamentally wrong because they only look at pixels and not the time aspect. For example, signs may start the same but end differently, like family and important. The best thing about our app is its accessibility. Simply go to computerpreter.streamlit.app and you're there. Let's look at how we got the data. For fingerspelling, which is having a hand shape for each of the 26 alphabet letters, like A, B, C, D, E, we self-film ourselves holding up each letter, and for each of the videos, we split it into 100 images for each letter. For dynamic sign, our data came from the WASL and MSASL datasets, and these had YouTube videos for signs. For data preprocessing for fingerspelling, we used MediaPipe's hands module to extract 21 hand landmark positions, both X and Y, for each image, and for dynamic sign, we used MediaPipe's holistic to extract landmark positions X, Y, and Z from the body, face, and hands, totaling 255 features for each frame in each video. Here is the code for training our fingerspelling random forest classifier. We had 26 labels, which are the 26 letters of the alphabet, and we reached an 100% accuracy. Here is our model architecture for our LSTM. We used batch input, padding, batch normalization, dropout, and packing to enhance trading. Then, next is our bidirectional LSTM layer. It was bidirectional for better context understanding. After that, we have two fully connected layers, and finally we get our softmax probabilities. The results of our LSTM was highly accurate.
Here's the demo video. Here's a deaf person.
I'm a hearing person, and today we're going to have a conversation using Computerpreter.
The deaf person would like to first use dynamic sign to communicate. As you can see, we showed the detected landmarks on the hands, face, and body. And after the deaf person signs, you can see the predicted word. And after the deaf person is fully done, we use the Open Routers API to translate the ASL into English, and you can see the text pop up in the chat box. Now, the hearing person would like to respond.
Because it's delicious and healthy. What's your favorite type of meat?
Then the hearing person clicks transcribe audio, and now we're using OpenAI's whisper model to transcribe speech to text. And now the deaf person would like to respond in fingerspelling. And here you can see the detected landmarks on the hand, but notice how fingerspelling is now continuous frames as opposed to dynamic sign. And after the deaf person is done, we have the fingerspelled word. And now the hearing person would like to respond.
That's really cool. Mine is steak.
We can click transcribe audio again for speech to text. And finally, both the deaf user and the hearing user can type in the chat box however they want to show some emojis or something like that. And thus, we have a successful conversation.
We envision deaf hearing conversations to happen on the phone, for convenience. A tablet is also fine. We interviewed our high school teacher and 29-year deaf educator, Miss Tully, and she said that Computerpreter will be especially useful at cyber traumatic events, and also for deaf people who have, for example, intellectual loss. Here are some images from our interview. We calculated that Computerpreter will save times by up to 62%, thus increasing accessibility and utility. In our Python code, we have a trained random forest classifier, we have our trained LSTM, and we have Streamlit plus GitHub code to package it all into one web app. Thank you.
Thank you.